Hey guys, so we're going to be getting started with our week 4 material, which is going to be dividing exponents. So obviously so far we've talked about multiplying, we've talked about raising a power to a power, all of that kind of stuff, negative exponents, zero exponents. So now we're going to get into dividing. So we're writing the following exponential expression in expanded form. So we're first just going to kind of talk it out and figure out what it would look like, and then I'll give you the actual trick that you'll use to be able to do this. So we're going to write this in expanded form. So hopefully you remember that this is going to be x times x times x times x times x over x times x. Then you can simplify. An x will cancel out and another one would cancel out. So we would be left with x to the third. So how many x's could we cancel? We could cancel 2 out. We were left with 3 x's, which is x to the third. So then if you consider that x to the third is our answer and we started with x to the fifth over x to the second, the rule we're going to use is that when we divide same bases, so both of our bases were x, that's important, we're going to subtract the exponents and we'll do the top minus the bottom. And then what's important is that the result will always go in the numerator. Now, I'm actually going to talk about that in a little bit. Sometimes I give a little bit of a different tip that works for some kids, some it doesn't. So we'll kind of see how that goes. Okay, so we're going to simplify and write these as a single power. So if we look at number 1, and as you kind of get used to this, you won't have to do all the steps I'm doing, but in the beginning, I think it's not a bad idea to kind of write some of that out. So x to the 10th over x to the 7th, same base, so I'm going to subtract my exponents. So x to the 10 minus 7. Remember, it always comes to the numerator when we do this. So 10 minus 7 is 3, so my answer is x to the third. Obviously, the more comfortable we get with doing this step that I just highlighted, you wouldn't have to write. You would just do the subtraction. Okay? Here we have 3 to the 5th over 3 to the 1st. Same basis, so I subtract the exponents. 3 to the 5th minus 1, which would be 3 to the 4th. And then you can go ahead and simplify. 3 to the 4th is 81. Okay? Okay. Number 3. Now we're kind of getting into multivariables, and that's fine. We can have that. There's nothing wrong with that. First thing I can do is simplify 4 divided by 12. 4 becomes 1, 12 becomes a 3. And then I can start doing my exponents. So if you notice, x to the 7th, x to the 4th would match up, y to the 2nd, and y to the 1st would match up. Okay, so I would be left with, I'm going to have 3 in the denominator. You can write the 1 up top, but you don't have to. X to the 7th divided by x to the 4th is x to the 3rd, right? And that always goes up top, always goes to the numerator. Y to the 2nd divided by y to the 1st, subtract the exponents, so it would just be y to the 1st or y, and that would be our final answer for that one. Number 4, I always like to simplify if I can up top or on the bottom before I do the division. X to the 7 times x to the 9th is x to the 16th. We learned that before. Divided by x to the 3rd, same base, so I subtract the exponents, so x to the 13th would be my answer. Okay? So now we're going to look at a situation where the larger exponents in the denominator. If you noticed, every time I did this division, the larger exponents were up top in the numerator. Now we're going to see what it looks like when it's in the denominator. Okay, so I'm going to show you 2 different ways you can think about it. Some ways work better for others. It's just a matter of, what makes the most sense to you. So for number 5, first way you can do it, and I'll do this in green, is you do it like normal. So you would just do same basis, so I subtract top minus the bottom. So y is equal to 5 minus 8. Remember, it always goes in the numerator. So this would be equal to y to the negative 3rd. The only issue is we don't like to have negative exponents. So now I need to bring that to the denominator. So it would be y is equal to 1 over y to the 3rd. So that's the first way. Second way, and what I think sometimes a lot of kids like, and I'll do this in blue, is I say to the kids, okay, let's say these y's are like fighting each other. The y's up top have 5, the y's in the bottom have 8. If they're going back and forth, who has more? Who's going to win? The y to the 8th. And how many, let's just say they're soldiers, right? How many soldiers would they have left? They would have 3 left in the bottom. So all the y's up top would be gone, but the y's in the bottom, there would be 3 left. Okay, so you can kind of think like soldiers are fighting each other. There's 5 soldiers up top, there's 8 soldiers in the bottom. Who's going to win? The soldiers in the bottom, because they would still have 3 left over. Okay, so that's 2 different ways of thinking about it. I obviously don't know which way you're going to find to be more comfortable. I will stick with the green way for now. And if you like the way I did in blue, go with that. Okay. So number 6, we have 4 to the second divided by 4 to the fifth, same base. So I subtract the exponents, 4 to the 2 minus 5, 4 to the negative third, which is the same as 1 over 4 to the positive third. And then 4 to the positive third is going to be 64. So 1 over 64 would be my answer there. Number 7, a to the third, b to the 10th, divided by a to the 5th times b to the 9th. So a to the third and b to the 5th. I'm sorry, a to the third and a to the 5th, and then b to the 10th and b to the 9th. Those are the sections we can combine. So I would have a to the third divided by a to the 5th would be a to the negative second up top. B to the 10th divided by b to the 9th would just be b to the first, or b. That's fine where it is. It's just this a to the second that's an issue. So I need to bring that down to the bottom. So that's going to look like b over a to the positive second. The b stays where it is. That was not negative. Next one, number 8. First thing I can do, 16 can become 8. 2 can become 1. I can simplify that. And then I can go ahead with the rest of it. So I'll have 8 up top. A divided by a to the third is going to be a to the negative second up top. B to the second divided by b to the 7th is going to be b to the negative 5th up top. Both of these are issues, a to the negative second and b to the negative 5th. So I can bring them to the bottom. 8 stays where it is. The 8's fine. A to the positive second, b to the positive 5th. Okay. And again, in number 8, you could have said, all right, well, if the soldiers in A and A to the third are going against each other, there would be 2 soldiers left over in the bottom. And B to the second and B to the 7th, 2 soldiers versus 7 soldiers, there would be 5 soldiers left in the bottom. So that's another way you can think about it. It kind of gets rid of that negative exponent part of it. Okay. So now this is something we've actually already done, but we're going to kind of keep working with it. So it's raising a quotient to a power. So when you raise a fraction to a power, you distribute the outside exponent to all of the inside exponents. But we've actually done this. So this is just kind of a review now. So a to the m over b to the m. This isn't new for us. We've already done stuff like this. So we're going to simplify each expression. So in number 9, the 3 is going to go to the 7, the a, and the b to the second. So we're going to have 7 to the third, a to the third over b to the 6th. I don't know what 7 to the third is. 49 times 7, 3, 6, 28, 343. So 343, a to the third over b to the 6th. This stuff should be very familiar. We've done this before. Distribute the 2, so it would be 2 squared over 3 squared, which is 4 over 9. Distribute the 4th power. Remember to put the negative 2 in parentheses. Negative 2 times negative 2 is positive 4, times negative 2 is negative 8, times negative 2 is positive 16 over x to the 4th. Last one, we have that negative first power. That negative first is going to go to the 3, to the x, or to the 4. If you remember the tip that I showed you guys last week, how you could have flipped the whole thing and made that outside exponent positive, you can also do that. 3 to the negative first, x to the negative first, over 4 to the negative first. Everything gets flipped. What's in the bottom comes up top. What's up top goes to the bottom. So then I would have 4 over 3x. You don't have to write anything to the first power because it just is the same as itself. Okay, moving on. Last 3 problems. We're going to simplify each of these exponential expressions. My suggestion is simplify what you have inside here before you distribute that power. Because when you distribute, it can get a little messy if you do it with so much there. So I would first start by making this negative 3 and making that 2, 1. Okay, and then from there, I can simplify x to the second over x. Okay, so let's write a new set of parentheses so we have this. So I have negative 3 up top, x to the second divided by x. It's going to give me positive x up top. y divided by y to the third. If you kind of follow that soldier method, that's like y to the first. So 1 soldier versus 3 soldiers, you're going to have 2 soldiers left in the bottom, and that's all being raised to the third power. Now it's a lot easier to distribute that third power to only 3 things versus 6 things. So then we're going to have negative 3 to the third, x to the third over y to the sixth. So then that would then be equal to negative 3 times negative 3 is positive 9 times negative 3 is negative 27 x to the third over y to the sixth. That would be our final answer for that one. Okay. Number 14. Again, my suggestion, simplify what's in here if you can. So x to the third divided by x. Remember, this 2 and this 3 are actually just going to stay where they are. There's nothing I can do with that. X to the third divided by x to the first. 3 minus 1 is 2, and it always goes up top, so x squared. Y to the fourth divided by y to the first. 4 minus 1 is 3. It's positive, stays up top, and that's all to the third power. So now I can distribute the third power to the 2, to the x squared, to the y to the third, and to the 3. So then I'm going to be left with 2 to the third, x to the sixth, y to the ninth, over 3 to the third. 2 to the third is 8, 8x to the sixth, y to the ninth, over 27. And that would be my answer. Okay, last one. Number 15. Again, I would simplify everything inside the parentheses first as much as you can. So first, simplify what's up top. We're going to have x to the 8th, because x to the 3rd times x to the 5th, we add the exponents, over x to the 12th, all to the negative first. I can still simplify what's in here. I can do the division. X to the 8th divided by x to the 12th. 8 soldiers up top, 12 soldiers on the bottom. All the soldiers will go away up top. You'll be left with 4 soldiers on the bottom, so x to the 4th. All to the negative first. Distribute that negative first power, or you can flip it. Remember that trick I showed you last week? So this would be 1 to the negative first over x to the negative fourth. Everything just gets flipped, which makes it x to the positive fourth. You can write over 1, but you do not have to. Okay, so those are our notes for this week. We're going to be pretty much just practicing all of this again next week. We might get into some more complicated problems, but all we're going to be doing is practicing this next week. There really isn't any new material. So hopefully you were able to kind of understand this and follow along with some of it. If you have any questions, we'll obviously be able to meet in that live session that I will be joining you guys in shortly. So I'll see you soon.